Right, question 11C, and wow, what's lovely about these questions is you're into them now. You've looked at this diagram and there's so much going on, but now you're into the question. So we've found a few things. We found what B and C are. I haven't put them in the picture here, but let's say that was 4, 2. This was minus 4, 2. And D, well, we spoke about it already. We can work out what it is, right, from the radius root 20, 0. Okay, so a whole lot of things there scribbled on the diagram, but that's great. I mean, as you're scribbling on the diagram, you're getting into it as well. So, maybe reading my scribbles isn't as useful, especially this root 20. I don't know what that is. Root 20. Close enough. Okay. So we asked the point D is where the circle crosses the positive x-axis. Find angle BDC in degrees. Okay, so we've got BD. Ooh, there we go. C. Okay, so there are a few things we can consider here, and that is we've got all the coordinates of these points. So B, D, C, we've also, if we made a little triangle over here, if we wanted to, close. So we've got BC, we've got CD, we've got BD. We can find all these lengths relatively easily. This one, of course, is the easiest because minus 2, which one's this? Is minus 4 to 4, so that's 8. CD, you could work out distance formula, Pythagoras, same thing. BD, same thing. So you got all the angles, and BDC, well, now you've got the cos rule if you wanted. That feels like one of the, easier options maybe. So you've got a triangle, and we've got, say, I'm just gonna go for AFG, just so it doesn't look like this one here. So we've got, let's call this F, that A, and that G. Then we know that G squared equals A squared plus F squared minus 2AF cos the angle in between, which is G. Okay, writing I'll work on. And also, I'm sure that just went beyond my head because I don't have it in front of me. I can't see what's there just yet. So G squared equals A squared plus F squared minus 2AF cos G. Okay, angle. So there's a cos rule there if you wanted. You could also maybe leverage some ideas that there's a circle, and if we have a radius, which we do, you know that angle there is going to be 90 degrees. May or may not be helpful, but just thinking in these types of questions. And there's one other thing I want to say here, because obviously you've got a way forward here, and that is you also have the concept of angle of inclination. So we know that we've got the gradient of a line, and if, let's say, that angle of inclination is theta, then m equals tan theta. Lots of scribbles over here, but I love the scribbles, right? So there, m equals tan theta is also an idea, so you could work out what this angle is. Here you've got maybe that gradient, this angle. That feels like a long method to do this, so perhaps not a great idea here. BDC, although you could work out the angle of inclination of BD and then BDC, well, you could just, work from there. So a few options. There may or may not be some other options to get into this as well, but at least there's some ideas, and yeah, have it a go. You've got the memo as well, so you can check through those details or ask any more on that. Hopefully helpful, at least a bit.